So the way machine learning or AI works is that you give it examples. So if you see this, predict this. If you see this, predict this. And you do this millions of times. And then what results is what we call a model or a deep neural net that when used on images it hasn't seen, the goal is, of course, to get it to predict the right answer. And the problem there is that if you train an AI and just sort of pulling cases from the world, it's going to be very good at the typical cases. But for the atypical stuff, the performance can be poor. So how do you do that? And then how do you sort of teach it for rare disease where you don't have a lot of examples? The way you do this is through data, through examples. And the most precise way to create data is through simulation, so data synthesis. So Riverain has been doing this for over a decade now. So in the context of something like vessel suppression, for example, where you're literally removing content from an image, you need to have a high degree of certainty that what you're doing in terms of suppression is highly accurate. So with simulation, you can create very exotic scenarios, things that would be rare and therefore likely for a traditional approach to fail on. But these are exactly the situations where radiologists need the most help. So by sort of showing a machine a lot of examples of this, it gets very, very good at that. Simulation in some respects solves the problem of needing large amounts of data to build complex models.